Now, in this lecture, we will find out the radius of the circle. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It is given us the equation that this line segment equals to 140 units and this line segment equals to 70 units. And our mission is to find out the radius of this circle. Okay, so first of all, we will give names with the relevant points in this drawing. So we will define this point, that is actually the touching point between this semicircle and the biggest semicircle is A. We define the center of this semicircle as B. We will define the touching point of this semicircle with the smallest semicircle as C. We will define the center of the biggest semicircle as point O. We will define the center of this the smallest semicircle as D, and we will define the touching point of the smallest semicircle with the biggest semicircle as E. We will define the center of this semicircle as F. We will define the touching point of this semicircle with this circle as G. And we will define the touching point of this circle with this semicircle as H. And finally, we will define the touching point of the biggest semicircle with this circle, this point as I. And we will also define the radius of the biggest semicircle as capital R and the radius of this circle as R. So I write it down. According to our definition, capital R is the radius of the biggest semicircle this is the biggest semicircle, and the radius of this circle equals to capital R according to our definition, and the radius of this circle we define as small r. Small r is the radius of the circle. It is given us in the question that line segment AE, this line segment, equals to 140 units plus 70 units. So I write it down. According to what is given us in the question, line segment AE is equal to 140 units plus 70 units. That is actually 110 units. So AE equals to 110 units according to what is given us in the question. AE equals to this line segment equals to 210 units. But what is actually line segment AE? It's very easy to see that line segment AE, for knowing that the line segment AE is the diameter of the biggest semicircle. Okay? And because of the fact that the diameter of any circle or semicircle is twice as long as the radius, and the radius of this semicircle, the biggest semicircle, is defined according to our definition, it is equal to capital R. Therefore, the diameter AE must be equal to twice of the radius capital R. So, the diameter AE must be equal to 2 times capital R. Okay? 2 times capital R. Two times capital R is the diameter of the semicircle, of the biggest semicircle. So from this long equation, we will derive that 2 times capital R equals to 210. We divide this equation by 2, and we get that capital R equals to 210 over 2 is 105. So we found out that the radius of the biggest semicircle, this semicircle, equals to 105 units. Capital R equals to 105 units. Line segment OA is the radius of the biggest semicircle. Why? Because O is the center of the biggest semicircle and A is the point on the biggest semicircle itself. This is exactly the definition of a radius. So OA is the radius of the biggest semicircle that is equal to capital R, but capital R equals to 105. So OA equals to 105 units. Line segment OA equals to 105 units, and it is the radius of the biggest semicircle, capital R. Likewise, according to the same, because of the same reason, line segment OE, it is also the radius of the biggest semicircle is equal to capital R. Why? Because line segment OE, this line segment, starts from the center of this biggest semicircle, that is to say from point O, and ends at point E, that is the point on the biggest semicircle itself. This is exactly the definition of a radius. OE is the radius of the biggest semicircle that is equal to capital R. We just right now found out that capital R equals to 105 units. Okay. Here, according to what is given us in the question, line segment AC equals to 140 units. But what is line segment AC? Line segment AC is the diameter of this semicircle. And because of the fact that the diameter of this semicircle equals to 140 units, it means that the radius of this semicircle must be equal to half of it. That is to say, the radius of this semicircle AB must be equal to 140 over 2, that is 70 units. AB equals to 70 units. And BO, it is also the radius of this semicircle, therefore it is also equals to 70 units. Repeat again, point B is the center of this semicircle, point C is the point on the semicircle itself here, therefore OC is the radius of this semicircle that is equal to 70 units. OC is this line segment. OC equals to 70 units. Again, CE, line segment CE, it is given as the question, it is equal to 70 units. But CE, it is actually the diameter of this smallest semicircle, and therefore the radius of the smallest semicircle, this smallest semicircle, must be equal to half of it. That is to say, the radius must be equal to 70 over 2, that is 35 units. That is to say, DE, the radius DE must be equal to 35 units, and the radius CD, it is also must be equal to 35 units in its length. I repeat again, point D is the center of the smallest semicircle, point C is the point on the smallest semicircle itself, therefore CD is the radius of this semicircle that is equal to 35 units, and for that reason also, for the same reason, DE is also the radius of this semicircle that is equal to 35 units in its length. So, what is the length of line segment BO? Repeat again the question, what is the length of this line segment BO? So, actually, from the drawing, it is very easy to see that BO or OB, line segment OB equals to OA minus BA. Again, OA minus BA equals to OB. OA minus BA equals to OB. OB equals to OA minus OB. So OB equals to OA. OA or AO is the radius of the biggest semicircle that is equal to 105 units, so we substitute OA by 105 minus BA. BA equals to 70 units, it is the radius of this semicircle, so we substitute BA by 70. In conclusion, found out that the length of this line segment OB, it is equal to 105 minus 70 units is 35. So OB equals to 35 units in its length. Likewise, we find out the length of this line segment OC. OC, from the drawing, it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. So OC equals to OE minus CE. I will repeat again. OC equals to OE minus CE. So OC equals to OE equals to 105 units. It is the radius of the biggest semicircle, so we'll substitute OE by 105 minus CE. CE equals to 35 plus 35, this is 70 units. So we substitute CE by 70. In conclusion, we found out that OC equals to 105 minus 70, that is 35 units. OC it is also equal to 35 units in its length. So we can write down in the drawing that the length of this line segment OC is 35 units. Okay. In the next step, I will present to you two new rules, and we will implement the two new rules in our drawing. Rule number 10. The first new rule is rule number 10. According to this rule, rule number 10, if two circles are touching each other internally, like in this drawing, the small circle is located inside the big circle, and the small circle touches the big circle at this point, point N. Point N is the touching point or the point of tendency of the small circle with the big circle. Okay, and therefore here we can see that the two circles are touching each other internally. That is to say, they have an internal notch between them at point N. Then the straight line that connects their centers together, the straight line, the center of the big circle is at this point, point O. The center of the small circle is at this point, point M. And the straight line that connects their centers together is OM. So this straight line OM, according to rule number 10, passes through their touching point. Their touching point is N, so OM passes through point N. So if OM passes through point N, it means that OMN is one straight line. Again, OMN is one straight line. Okay? And what is the distance between their centers? The distance between their centers is OM or MO. And what is the length of MO? That is the distance between their centers. From the drawing, it is very easy to see that line segment OM equals to NO minus NM. Again, NO minus NM equals to the distance between their centers, MO. NO equals to capital R. NM equals to small r. It is the radius of the small circle, and here capital R NO is the radius of the big circle. And therefore the distance between their centers, MO, equals to capital R minus small r. So whenever you have an internal notch between two circles, that is to say, if they touch each other internally, like in this drawing, then the distance between their centers will be equal to the difference between their radii. That is to say, it is equal to capital R, that is the radius of the big circle, minus small r, that is the radius of the small circle. So here MO equals to capital R minus small r, or MO that is equal to D equals to capital R minus small r. Okay? And we also have rule number 11 that talks on two circles with an external knot between them, like in this drawing. So if two circles are touching each other externally, like in this drawing, the big circle touches the small circle at this point, point N. Point N is the point, the touching point or the point of tendency between the two circles. And because of the fact that none of those two circles are inside the other, therefore the two circles are touching each other externally at point N. Okay? Here, the small circle is inside the big circle, and therefore those two circles are touching each other internally at point N. We have at point N internal knot between them. While here, none of those two circles are inside the other, and therefore they are touching each other externally at point N. Okay? So if two circles are touching each other internally at point N, like in this drawing, then the straight line that connects their centers together, here point O is the center of the big circle, point M is the center of the small circle, and OM is the straight line that connects their centers together. So this straight line OM, according to rule number 11, this rule number 11 passes for point N, that is their touching point. That is to say, O and M is one straight line. Okay, so whenever we have an external knot between two circles like in this drawing, then the straight line that connects their centers together, OM, must pass for point N. Or O and M is one straight line. Okay? And what is the distance between their centers? The distance between the centers of those two circles is OM, line segment OM. What is the length of OM? From the drawing it is very easy to see that OM equals to ON plus NM. ON plus NM equals to OM. So OM equals to OM, that is capital R, that is the radius of the big circle, plus NM, that is small r, that is the radius of the small circle. So in conclusion, you can say that the distance between the centers of two circles that they have an external knot between them equals to the addition of the two radii of the circles with each other, capital R plus small r. Okay, while if we have an internal knot between two circles, like in this drawing, then the distance between the centers OM equals to the difference between the radii. That is to say, this capital R minus small r. Okay? So actually, you can implement rule number, the two new rules in our drawing. Why? Because in our drawing, if we connect the center of this semicircle that is located here at point B with the center of this circle that is located here at point F, then the straight line that connects their centers together is BF. The circle, this circle and this semicircle have an external knot between them at point H. Therefore, according to rule number 11, the straight line that connects their centers together, BF, must pass for their touching point, that is actually point H. That is to say, BHF is one straight line. Okay, BHF is one straight line. And whenever we have an external notch between two circles, like here in our drawing, the distance between the centers of the two circles, that is to say FB, will be equal to the addition of the two radii with each other. The radius of this circle, according to our definition, equals to r. F edge equals to small r. The radius of this semicircle equals to 70 units. Here HB equals to 70 units. Therefore, it is very easy to see that the distance between the centers of the two circles FB or BF is 70 units plus r. So you can write down that line segment BF, that is the distance between the centers of this semicircle and this circle, equals to 70 plus 70 units plus r units. 70 plus r units. So I write down that line segment BF equals to 70 plus r units. Likewise, we connect the center of the smallest semicircle that is located here at point D with the center of this circle that is located here at point F. This semicircle, the smallest semicircle, and this circle have an external notch between them at point G. That is to say, they are touching each other externally at point G. And therefore, the straight line that connects their centers together is DF or FD, must pass for their touching point, that is actually point G. Or in other words, FGD is one straight line. FGD is one straight line. And the distance between their centers is FD. Why? Because F is the center of the circle and G is the center of the smallest semicircle. Therefore, FD is the distance between their centers. And according to rule number 11, the distance between two circles that have an external notch between them will be equal to the addition of the two radii with each other. The radius of this circle equals to small r. So FG equals to small r, and the radius of the smallest semicircle GD equals to 35 units. So GD equals to 35 units, and therefore the distance between their centers FD equals to small r plus 35 or 35 plus small r. Again, DF equals to DG plus GE. DF equals to DG plus GE. DG equals to 35 units, G equals to small r, therefore in total FD equals to 35 plus r units. So DF equals to 35 plus r units. Okay, 97 FD, this is the distance between the smallest semicircle and this circle, equals to 35 plus r units in its length. And what is the distance between points B and D? Or the distance, point B is the center of this semicircle, point D is the center of the smallest semicircle. So, and this semicircle have an external notch with this smallest semicircle. and they're actually touching each other externally at this point, point C. Therefore, BD is the distance between their centers. So BD is the distance between those two semicircles, the centers of those two semicircles that have an external knot between them at point C. And therefore, the distance between their centers BD will be equal to the addition of their radii with each other. The radius of this semicircle equals to 70 units. The radius of this semicircle equals to 35 units. And therefore, 70 plus 35 units equals to 105 units. So in conclusion, we found out that the length of line segment BD equals to 105 units. And this is actually the distance between the two semicircles. Okay. In the next step, we will join the center of the biggest semicircle that is located here at point O with the center of this circle that is located at point F. Okay. So here we have the straight line OF, and the biggest semicircle have an internal knot with this circle at point I. And whenever we have two circles or semicircles that have an internal knot between them, then according to rule number 10, the straight line that connects the centers together, that is to say OF, must pass through their touching point, that is actually point I. That is to say OFI is one straight line. Here OFI is one straight line. And OF or FO is the distance between their centers. Why? Because point O is the center of the biggest semicircle, point F is the center of this semicircle, of this circle, and therefore FO is the distance between their centers. And whenever we have an internal knot between two circles, then the distance between their centers, according to rule number 10, will be equal to the difference between their radii. That is to say, will be equal to the radius of the big circle, the biggest semicircle, that is equal to 105 units, minus the radius of this circle, that is equal to small r. Okay? I repeat again, whenever we have an internal knot between two circles, then the distance between their centers will be equal to the difference between their radii. The radius of the biggest semicircle equals to capital R. The radius of this circle equals to small r. And the distance between their radii will be equal to capital R minus small r. Here, OF equals to capital R minus small r. And because of the fact that capital R equals to 105 units, so we substitute capital R, right, 105, and we got that OF equals to 105 minus R, that is the radius of the circle. Okay, here we can write down that IF or FI, it is of course the radius of the small circle that is equal to small r, and we found out that the distance between their centers is 105 minus r units. 105 minus r units. Okay, so in the next step, I will present to you a new rule, and we'll implement the new rule in the green triangle, triangle FBD. Okay, this is the green triangle, is triangle FBD. The new rule is called Stewart's Theorem. Stewart's Theorem. And it is true in any triangle. Therefore, this triangle, triangle ABC, could be any triangle. Side AB of triangle ABC, that could be any triangle, equals to A units in its length. Side AC equals to B units in its length. And finally, side BC, this side is equal to C units in its length. And we also have here line segment AO that is equal to D units in its length. We also know that line segment BO equals to M units, and line segment OC equals to N units in its length. Then, according to Stewart's theorem, the following equation is true: that A squared times N, A squared times N, plus B squared times M equals to C, and inside the brackets we have D squared plus M times N. Repeat again, on Stewart's theorem, that is true in any triangle: A squared times N plus B squared times M equals to C. C is the length of side BC. Inside the brackets we have D squared plus M times N. Okay, we can actually implement Stewart's theorem in our triangle, in our green triangle, because this theorem is true in any triangle. So I'll copy the green triangle in a new page, and we'll implement on it Stewart's theorem. Okay. See? So we already found out all the sides of the green triangle. I will not repeat on it. We have triangle FBD. We have already found out that FB equals to 70 plus R units in its length. Side FD equals to 35 plus R units in its length. And finally, side BD. So actually, what is the length of side BD? Again, we have already found out that the length of side BD equals to 105 units. Here, BD equals to 105 units. So I write it down. BD equals to 105 units. And we have line segment FO. We've already found out that line segment FO, this line segment equals to 105 minus R units, minus small r units. What is the length of side OD? From the drawing it is very easy to see that OD equals to 35 plus 35 units, it is 70 units. Yeah. OD equals to 70 units in its length. What is the length of BO? We already found out that the length of line segment BO is 35 units. Yeah. BO equals to 35 units. So when you hear that, we found out that BO or OB is the same, it is equal to 35 units in its length. Okay, BO equals to 35 units. So this is the green triangle FBD, that I copied from the original drawing. So we'll implement on it Stewart's theorem. According to Stewart's theorem, in this triangle FBD, FB squared times OD plus FD squared times BO FD squared times BO equals to BD, this side BD. Inside the brackets we have FO squared plus BO times OD. So this equation is the implementation of Stewart's theorem in our triangle FBD. I'll repeat again. In our triangle FBD, according to Stewart's theorem, FB squared times OD plus FD squared times BO equals to BD. Inside the brackets we have FD squared plus BO times OD. Okay? FB is 70 plus 1, 70 plus R, therefore FB square is 70 plus R square times OD. OD is 70 units, so it's OD by 70 plus FD square. FD equals to 35 plus R, therefore FD square is 35 plus R square times BO. BO is 35, so it's BO by 35. So in conclusion, this side of the equation we have 70 plus R square times 70 plus 35 plus R square times 35, and it is equal. On the other side of the equation we have BD. BD is 105, so we substitute BD by 105. Inside the brackets we have FO square. FO is 105 minus R, therefore FO square is 105 minus R square plus BO, that is 35, times OD, that is 70. So on the other side of the equation we have 105, and inside the brackets we have 105 minus R square plus 35 times 70, all inside the brackets. Okay. In the next step, we will define 35 as x, and we substitute 35 for the multiplication of 35 by any natural number by x, and we will get that here we have 70 plus R square. 70 is 35 times 2, that is to say it is 2x, and we have inside the brackets 2x plus R square times 70 is 2x plus, here we have 35 plus R square. 35 is x, so we substitute 35 by x. So here we have x plus R square times 35 is x, so we substitute 35 by x. So in this side of the equation we found out that 2x plus R square times 2x plus x plus R square times x equals to, on the other side of the equation we have 105. 105 is 35 times 3, that is to say it is 3x. Inside the brackets we have again 35 is 3x minus R square plus 35 is x times 70 is 2x. Okay. So on the other side of the equation we have 3x, and inside the brackets we have 3x minus R square plus x times x. Okay. So here we will divide this equation by x, and we get that here x will get cancelled, here also x will get cancelled, and finally here also x will get cancelled. So what is left from our equation of the cancelled x? In this side of the equation we have 2x plus R square times 2 plus x plus R square, and on the other side of the equation we have it is equal to 3, and inside the brackets we have 3x minus R square plus x times 2x is 2x squared. In conclusion, we found out that according to Stewart's theorem, in our triangle FBD, 2 times 2x plus r squared plus x plus r squared equals to 3. Inside the brackets we have 3x minus r squared plus 2x squared. Here we will open the brackets. We have here 2 times. Inside the brackets we have 2x plus r squared. 2x plus r squared, according to the algebraic identity that a plus b squared equals to a squared plus b squared plus 2ab, we get the 2x plus r squared equals to 2x squared, that is 4x squared, plus r squared, plus 2 times 2xr is 4xr. Okay, and we have also plus x plus r squared. X plus r squared is x squared plus r squared plus 2xr. And it must be equal to 3. Inside the brackets we have 3x minus r squared. 3x minus r squared, according to the algebraic identity that a minus b squared equals to a squared plus b squared minus 2 times ab, we get that 3x minus r squared equals to 3x squared, that is 9x squared, plus r squared, minus 2 times 3xr is minus 6xr, plus 2x squared, all under the brackets, inside the brackets. So here we will open the brackets and we get that 2 times 4x squared is 8x squared, two times r squared is 2r squared, and 2 times 4xr is 8xr. And in the other side of the plus, we have to add also plus x squared plus r squared plus 2xr. On the other side of the equation we have 3, and inside the brackets we have 9x squared plus 2x squared is 11x squared plus r squared minus 6xr. So on this side of the equation we have 8x squared plus x squared is 9x squared. 2r squared plus r squared is 3r squared. And finally 8xr plus 2xr is 10xr. So in total, on this side of the equation we have 9x squared plus 3r squared plus 8xr, and it is equal to 3 times 11x squared is 33x squared. 3 times r squared is 3r squared, so it is plus 3r squared. And finally, 3 times minus 6xr is minus 18xr. So, here in this equation we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step we will subtract 9x squared from this equation. And we will get that 9x squared minus 9x squared is 0, so in this side of the equation we left only with 10xr. That is equal to 33x squared minus 9x squared is 24x squared minus 18xr. In conclusion, we found out that 10xr equals to 24x squared minus 18xr. Here we will add 18xr to this equation, and we'll get that 10xr plus 18xr is 28xr, and it is equal to 24x squared. So In conclusion, we found out that 28xr equals to 24x squared. Here we divide this equation by x and we get that 28xr over x is 28r, and it is equal to 24x squared over x is 24x. So here we will substitute x by, again, we found out that 28r equals to 24x. Here we will substitute x by 35. According to our definition, x equals to 35. And we get that 28r equals to 24 times x, and x is 35. The conclusion found out that 28r equals to 24 times 35. Okay, here we will divide this equation by 7. And we'll get that 28r over, or 28 over 7 is 4, so in this of the equation we have in total 4r. That is equal to 24, and 35 over 7 is 5. So in conclusion, we found out that 4r equals to 24 times 5. Here we will divide this equation by 4 and we get that 4r over 4 is r, and it is equal to 24 over 4 is 6. So in total, this side of the equation we have 6 times 5. So r equals to 6 times 5, that is 30. So we found out that r, the radius of the circle, equals to 30 units in its length. Then we found out that the radius of this circle r equals to 35 units. It equals to 30 units. R equals to 30 units in its length. And that is the answer to our question. In the next step, I will summarize the lecture. In the drawing, we have a big semicircle. Inside this big semicircle, we have two smaller semicircles and one circle. It is given us the question that line segment AC equals to 140 units in its length, and this line segment C equals to 70 units in its length. Our mission is to find out the radius of this circle. Okay, so first of all, we gave names to the relevant points, and then we defined the radius of the biggest semicircle is capital R, and the radius of this small circle is small r. Repeat again. Capital R is the radius of the biggest semicircle, and small r is the radius of the circle. Actually, it is given us the question that line segment AE equals to 140 plus 70, that is 210 units. Repeat again. Line segment AE equals to 140 plus 70, that is 210 units. And what is exactly line segment AE? Line segment AE is the diameter of the biggest semicircle, and therefore it must be twice as long as the radius of the biggest semicircle. And because of the fact that according to our definition, the radius of the biggest semicircle equals to capital R, therefore AE must be equal to 2 times capital R. So the diameter of the biggest semicircle AE equals to 2 times capital R. The diameter of the biggest semicircle equals to 2 times capital R. But we already found out that A equals to 210 units. And from this long equation we can conclude that 2R equals to 210 units. 2R equals to 210 units. We divided this equation by 2 and we found out that capital R equals to 105 units. So capital R, the radius of the biggest circle, equals to 105 units in its length. Yeah. OA is the radius of the biggest semicircle, that is 105 units, and OE is also the radius of the biggest semicircle. Why? Because it starts from point O, that is the center of the biggest semicircle, and that's at point E, that is the point of the biggest semicircle itself. This is exactly the definition of a radius. So OE equals to 105 units, that is the radius of the biggest semicircle, capital R. Okay. Then we know, according to what is given as the question, this line segment AC equals to 140 units. But what is line segment AC? Line segment AC is the diameter of this semicircle. So if the diameter of this semicircle equals to 140, it means that the radius AB must be equal to half of it, that is to say it is 140 over 2, that is 70. And the radius BC, it is also 140 over 2, that is 70 units. Likewise, it is given as the question that line segment CE equals to 70 units. But what is CE? CE is the diameter of this semicircle. So if the diameter of this semicircle equals to 70 units, it means that the radius CD must be equal to 70 over 2, that is 35 units, and also DE must be also equal to 35 units. Then we found out the length of line segment BO. From the drawing it is very easy to see that BO or OB equals to OA minus BA. Again, OA minus BA equals to OB. I repeat again. OB or BO equals to OA minus BA. OA is the radius of the biggest semicircle, that is equal to 105 units. Or AB is the radius of this semicircle, that is equal to 70 units. Therefore, in conclusion, found out that the length of line segment AB is 105 minus 70 units. 105 minus 70 is 35. So OB equals to 35 units in its length. Then we found out the length of this line segment CO, or OC. From the moment it is very easy to see that OC equals to OE minus CE. Again, OE minus CE equals to OC. I'll repeat again, OC equals to OE minus CE. So OC equals to OE is 105, CE is 70, so OC equals to 105 minus 70, this is 35 units. Line segment OC equals to 35 units in its length. Okay, then I presented to you 2 new rules and we implemented the 2 new rules in our drawing. According to rule number 10, if 2 circles are touching each other internally, like in this drawing, this circle is located inside the big circle and it touches the big circle at point N. That is to say, they have an internal notch between them at point N. Point N is their touching point. Okay? So if 2 circles are touching each other internally, like in this drawing, then the straight line that connects their centers together, the center of the big circle is at point O, the center of the small circle is at this point, point N. And the straight line that connects their centers together is the straight line OM. According to this rule number 10, the straight line OM must pass for the attaching point, that is actually point N. OM must pass for point N, that is to say OMN is one straight line. Okay, OMN is one straight line. And what is the distance between their centers? The distance is OM. The distance OM from the domain is very easy to see that OM equals to NO minus NM. NO minus NM is OM. NO is capital R, NM is small r. So the distance OM equals to capital R minus small r. So whenever you have an internal arc between two circles, then the distance between their centers will be equal to the difference between their radii. In this case, it is capital R minus small r. Okay, then I presented to you rule number 11. According to rule number 11, if two circles are touching each other externally, like in this drawing, those two circles are touching each other externally at point N. Why it is defined as externally? Because of the fact that none of those two circles are inside the other. Therefore, they are touching each other externally at point N. So the straight line that connects their centers together, point O is the center of the big circle, point N is the center of the small circle, and OM is the straight line that connects their centers together. This straight line OM must pass for the attaching point, that is actually point N. If OM must pass for point N, it means that O and M is one straight line. O and M is one straight line. And what is the distance OM between their centers? The distance OM is ON plus NM. ON equals to capital R, NM equals to small r, and therefore the distance between their centers OM is capital R plus small r. In other words, whenever we have an external arc between two circles or semicircles, the distance between their centers will be equal to the addition of the radii with each other. In this case, it's capital R plus small r. We can actually implement the two new rules in our drawing. Because in our drawing, we have the center of this semicircle is at this point, point B. We joined the center of this semicircle with the center of this circle that is here at point F. This circle has an external arc with this semicircle, that is to say they are touching each other externally at this point, point H. And whenever we have an external arc between them, then the straight line that connects their centers together, that is FB, must pass from point H, that is their touching point. Or FHB is one straight line. FHB is one straight line, and what is the distance between their centers? What is the length of line segment FB? It will be equal to small r, that is the radius. FB equals to FH plus HB. FH is small r, HB equals to 70 units. This is the radius of this semicircle, and therefore, in conclusion, found out that the distance FB between the centers of this semicircle and this circle is 70 plus r units. FB or BF equals to 70 plus r units. Likewise, we connected the center of the smallest semicircle that is located here at point D with the center of this circle that is located here at point F. This smallest semicircle have an external arc with this circle at point G. That is to say, they are touching each other externally at point G. And therefore, the straight line that connects their centers together, FD, must pass for point G, that is their touching point, or FGD is one straight line. Okay? FGD is one straight line, and what is the length of FD? The length of FD equals to FG plus GD. FG is the radius of this circle that is equal to small r, and GD is the radius of this smallest semicircle that is equal to 35 units. In total, FD equals to 35 plus R units. Here FD or DF equals to 35 plus R units. And what is the distance between points B and D? Point B is the center of this semicircle. Point D is the center of the smallest semicircle. Those two semicircles have an external arch between them at point C. That is to say, they are touching each other externally at point C. Therefore, the distance between their centers, that is BD, will be equal to the addition of their radii with each other. And the radius of this semicircle equals to 70 units. The radius of this semicircle equals to 35 units. So the addition of their radii is 70 plus 45, that is 105 units. In conclusion, found out that BD equals to 105 units. Then we added the center of the biggest semicircle that is located here at point O with the center of this circle that is located here at point F. So the straight line that connects their centers together is OF, of course. And according to rule number 10, whenever we have an internal arch between two circles, then the straight line that connects their centers together, that is to say OF, must pass through their touching points. That is actually point I. OFI is one straight line. OFI is one straight line. And what is the distance between their centers? FO, the distance FO will be equal to the difference between their radii. That is to say, the radius of the biggest semicircle is capital R, the radius of this circle is small r, therefore capital R minus small r is the distance FO between their centers. So FO or OF equals to capital R minus small r. Capital R is 105, so we substitute capital R by 105 minus small r. So in conclusion, found out that OF equals to 105 minus R units. In the next step, I presented to you a new rule, and we implemented the new rule in our main triangle FBD. The new rule is true in any triangle. The new rule is called the Stewart's Theorem. According to Stewart's Theorem, we have here triangle ABC that could be any triangle. We know that the length of side AB is A units, side AC equals to B units in its length, and side BC equals to C units in its length. In addition, we know that line segment AO equals to D units in its length, line segment BO equals to M units, line segment OC equals to N units in its length. Okay? Again, I repeat that line segment BC equals to C units in its length. Okay? So, according to Stewart's theorem, the following equation is true. And because of the fact that this triangle ABC could be any triangle, Stewart's theorem is true in any triangle. So here we will get that the following equation is true. That A squared times N plus B squared times M equals to C. C is the length of BC. And then we have inside the brackets D squared plus M times N. Okay, I repeat again, A squared times N plus B squared times M equals to C. And inside the brackets we have D squared plus M times N. So we implemented the new rule Stewart's theorem in our triangle, the green triangle, triangle FBD. So I copy triangle FBD in a new page, and we implemented here Stewart's theorem. I will not repeat on the length of the sides. We have already found out the length of the three sides. And we already found out that FO equals to 105 minus R. What is the length of BO? BO, according to what we have already found out, BO equals to 35 units. what is the length of line segment OD? For the drawing, it is very easy to see that OD equals to OC plus CD. OC plus CD. OC equals to 35 units and CD equals to 35 units also, and therefore in total OD equals to 35 plus 35, that is 70 units. Here OD equals to 70 units. So in the next step we implemented in this triangle FBD Stewart's theorem. According to Stewart's theorem, in this triangle FBD, FB squared times OD plus FD squared times BO equals to BD. Inside the brackets we have FO squared plus BO times OD. Again, FB squared times OD plus ED squared times BO equals to BD. Inside the brackets we have FO squared plus BD times OD. Okay, this equation is the implementation of Stewart's theorem in our triangle FBD. FB equals to 70 plus R, therefore FB squared is 70 plus R squared times OD. OD equals to 70, so we substitute OD by 70. Plus ED squared. ED is 35 plus R, therefore ED squared is 35 plus R squared times BO. BO is 35, so we substitute BO by 35. And in the other side of the equation we have BD. BD is 105, so we substitute BD by 105. Inside the brackets we have FO squared. FO equals to 105 minus R, therefore FO squared equals to 105 minus R squared plus BD times OD times plus BO times OD. BO equals to 35 units and OD equals to 70 units, all under the brackets. In the next step we defined 35 as X and we substituted 35 for the multiplication of 35 by any natural number by X. So here we have 70. 70 is 2 times 35. That is to say it is 2x. So 2x plus R squared times 70 is 2x plus 35 plus R squared. 35 is x. So we substitute 35 by x and we got that x plus R squared times 35 is x. So we substitute 35 by x. In conclusion, we found out that in this side of the equation, after the substitution of 35 by x, that 2x plus R squared times 2x plus x plus R squared times x equals to 105 is 3 times 35, so we substitute 105 by 3x. Inside the brackets we have 105, that is 3x, so it is 3x minus R squared plus 35 is x and 70 is 2x. So 35 plus 7 times 70 is 2x, it is x times 2x. Here we divided this equation by x. So here x will get cancelled, x will get cancelled, and here also x will get cancelled. So what is left from this equation after we cancelled x? What is left is actually, here we have two times 2x plus R squared plus x plus R squared equals to 3. Inside the brackets we have 3x minus R squared plus 2x squared. Here we open the brackets of 2x plus R squared. 2x plus R squared equals to, according to the algebraic identity, that a plus b squared equals to a squared plus b squared plus 2 times ab. So 2x plus R squared equals to 2x squared, that is 4x squared, plus R squared plus 2 times 2xr, that is 4xr. And it is equal to x plus R squared. X plus R squared is x squared plus R squared plus 2xr. And the other side of the equation we have 3 inside the brackets we have 3x minus r square. 3x minus r square according to the algebraic identity that a minus b square equals to a square plus b square minus 2 times ab. It will be equal, 3x minus r square will be equal to 3x squared, that is 9x squared, plus r squared minus 2 times 3xr, that is minus xr, minus 6xr, plus 2x squared. Here we open the brackets. We got 2 times 4x squared is 8x squared, 2 times r squared, 2 times r squared is 2r squared, and 2 times 4xr is 8xr, plus x squared plus r squared plus 2xr. Okay, we copy this expression without any change. And it is equal to, inside the brackets we have 9x squared plus 2x squared is 11x squared. And we have also plus r squared minus 6xr. Here we have 8x squared plus x squared is 9x squared. 2r squared plus r squared is 3r squared. And we have here 8xr plus 2xr is 10xr. So in total, in this side of the equation, we have 9x squared plus 3r squared plus 10xr. In the other side of the equation, we open the brackets. 3 times 11x squared is 33x squared, and 3 times r squared is 3r squared, and 3 times minus 6xr is minus 18xr. Okay, we subtracted 9x squared from this equation, and found out that first of all we have 3r squared on both sides of the equation, so 3r squared will get cancelled. In the next step we subtracted 9 squared from this equation, 9x squared from this equation. 9x squared minus 9x squared is 0, so in this side of the equation we're left only with 10xr, and it is equal to 33x squared minus 9x squared is 24x squared minus 18xr. In conclusion, found out that 8xr equals to 24x squared minus 18xr. Here we added 18xr to this equation, and we found out that 10xr plus 18xr is 28xr, that is equal to 24x squared, because 18xr minus 18xr is 0. So in conclusion, we found out that 28xr equals to 24x squared. We divided this equation by x. 28xr over x is 28r, and 24x squared over x is 24x. So we found out that 28r equals to 24x. Here we substitute x by 35. According to our definition, x equals to 35. And we found out that 28r equals to 24 times x, and x is 35. So in conclusion, we found out that 28r equals to 24 times 35. Okay. Here we divided this equation by 7, and found out that 28 over 7 is 4, so in total in this side of the equation we have 4r, and we have 24, 35 over 7 is 5. So in this side of the equation we have in total 24 times 5. Or actually found out that r equals to 24 times 5. Here we divided this equation by 4, and we found out that 4r over 4 is r, and 24 over 4 is 6, so in total in this side of the equation we have 6 times 5. So r equals to 6 times 5, that is 30 units. So we found out that the radius that we are looking for, the radius of this circle small r equals to 30 units in its length. And that is the answer to our question. Okay, thank you very much.